Robots hold infinite promise, but nobody can build the future alone. We have to do it together. Misty is the next step. What else can she do? I can't wait to find out.
Well, so when I was just a little kid, probably 3 or 4 years old, far back as I can remember, I had this little cardboard box, and I would take apart like broken stuff that my parents had, like cameras and cassette players, and I wanted to understand how they worked, and I would like keep all the parts in this cardboard box. So I've always liked to take things apart and understand how they worked, and I think that was kind of the beginning. When I was 11 years old, I was actually homeschooled at the time. I started homeschooling a few years in, and my dad and I went to this computer club, and he's a musician, and he wanted to get into digital music recording, and he met this guy that taught electronics at a university. And he knew that I liked to tinker with things and take things apart. So he thought I might be interested in electronics. So he started teaching this guy guitar in exchange for this guy teaching me about electronics. And from then on, I was just totally hooked on robotics and taking things apart and CD players and getting parts out and building tons of robots. And that's pretty much all I did through school, and then studied that university, and I still do that. The science and engineering part. So there's mechanical engineering. So an issue that we're struggling with right now and working through at Misty is heat. So we have some processors in the head, so the little computer chips that run the robot. And when we do things that are very computationally intensive, like recognizing faces, recognizing objects, or driving around, and the robot can actually create a map of your house, these chips get very hot. And how do we get that heat out of Misty's head? And one of the other challenges is usually to cool things down, you use a fan. But the problem is on the top of Misty's head, there's actually 3 microphones, because we want Misty to be able to do voice recognition. And when you put a fan next to a microphone, it doesn't work very well. So we have to build something that's very silent, that can remove heat. And it's a very challenging engineering problem. So that's mechanical engineering. There's lots of software engineering. So obviously there's lots of code that's running in Misty to display her eyes and allow her to drive around smoothly and things like that. And then also things like artificial intelligence. That's becoming bigger now. So lots of software engineers working on that part of Misty. And then electronics, so pulling all the sensors together. So she has different sensors to detect maybe the edge of your stairs so she doesn't drive off, or cameras so that she can recognize you, or other sensors to map your space, touch sensors. So the electronics, the circuit boards inside of Misty, we have lots of electrical engineers working on that part too. There's definitely, like you said, not just the art of what Misty looks like and make sure she's pretty, but all the engineering that goes into our robots as well. Well, it started to come from when we're working on BB-8 and other products at Sphero, and thinking, well, it's super fun. Like you can program BB-8, you can interact with him, you can do all different kinds of things, but what if we had like a real BB-8, a real R2-D2, like something like actually in our houses doing these mundane things, making our beds and making lunch and all that kind of stuff. Why can't we make that? And seeing technology today at a point where we can actually start to do useful things with robots that's not just robot arms in a factory welding cars, but more interesting things. So things like voice recognition. So a lot of work from Amazon and other companies in that space. Computer vision and being able to do mapping. So these technologies that you would actually need to make a robot that can do useful stuff. So just got really excited about it and started digging in more and building some prototypes and realizing that I think we can actually build that first robot and get it out to software developers so that people can actually start writing these different skills for the robot. And that's what we're doing. So lots of iterations. So we probably went through 150 different visual designs for Misty. And then there's probably, I would say there's probably 10 or 15 out of that 150 that we actually built. And by built, they probably didn't work. Most of them, we would just design a rough version in CAD, computer tool to design mechanics, and then 3D print it to just see what it looked like. And because there's definitely a difference when you see something on your computer screen versus when you can actually see it in real life. So we went through lots of different iterations. There was probably 3 or 4 of those that were actually more functional, they could move around. And what we were trying to do is we were trying to get something that was the size of Misty. So we were trying to think of something that wouldn't take up too much room in your house, but not something too small, because then you're going to trip over it and stuff like that. She's driving around. We wanted something that was friendly, that you could, that doesn't necessarily look like we don't want it to look like a person. We want it to look like a robot, but we wanted Misty to be able to convey her emotions to you. So there's certain elements like neck and eyes that allows her to do that, eyebrows. And then when we sort of take that to manufacturing, so we manufacture our products in Asia. So I've spent about 2.5 years basically with our manufacturer in Asia, working with them and collaborating and testing and refining. And so we go to them and they basically take our rough drawings and turn that into something that can actually be manufactured. So company-wide, we have, tons of different disciplines. On my particular team, I actually have an artist. So he can concept different things, like he'll work on, so for instance, one project is we didn't have speakers in one of the early prototypes, but we needed to put it in. So he had to figure out how to make the speaker grills so that it looked good and like fit in with the industrial design of the robot and didn't look strange. And then across the company, we have marketing people. We have people that build our website. We have people that write the software and do all the engineering. We have sales people. It's, again, with robots, it's, in one way it's difficult because you need so many different types of people to make a robot. And then to make a robotics company, you need even more people. Sure. So we wanted to give developers enough features that they could do lots of different things. But we were trying to balance that with not too much, because we can't put everything in there because then it gets really expensive and then it would take us like 10 years to figure out how to make it. Yeah. So she has a screen in the face, so she has eyes, and you have access to that, so you can change her personality, or you could play a video or something in the eyes. This bar up here, we have sensors. It's kind of like an Xbox Connect. Mm-hmm. So it creates a 3D image of the world, and then there's lots of software that can turn that into a map as she's driving around. So you can say, "Hey, Misty, can you go to my bedroom?" She knows how to get there. There's In her head, there's 3 little holes where there's microphones. So she knows where you're speaking around her and she can recognize your voice. There's some little LEDs here. There's capacitive touch. And what that means is it's a technology like in the screen of your smartphone that knows where you're touching her. So if you touch the side of her head, she can look at you. There's speakers. She can look around with her neck and she can tilt a little bit. Arms, she has this LED down here that you can change the color. She has bump sensors, so she knows if she runs into things. There's these 3 little holes where there's sensors to detect obstacles in front of her. There's more sensors, downward facing sensors, so she can detect your stairs, so she doesn't drive off. She can drive around and move. And then she has a backpack in the back that you can pop off. It's magnetic. And if some of you have heard of an Arduino, so one of these boards, you can actually attach. We have an Arduino. It looks different, but it's actually the same. We have an Arduino backpack that you can snap in the back like that. And now you can take your Arduino projects and make them robot enabled. And it works with all these, if you're familiar with Arduino shields, these all plug in. Most of your existing Arduino shields will plug into the back of Misty, and you can do stuff like, see if this is gonna work. So you don't even need the Arduino, you can just get power out. So this is the one that I created. Power's on. So this one's a laser pointer arm. So the arm is just one screw and it pops off and you can 3D print your own arms. This is another gripper arm. So the arms don't have hands, but if you wanted to be able to grab stuff, this is a gripper arm that would screw on. I made if you wanted to deliver your coffee in the morning, we have the cup holder arm. You can create all kinds of different things. With the backpack, there's a trailer hitch here. It's also magnetic. Yeah. So you can create like a little trailer that she tows around. You can deliver, school supplies or mail or something. And then there's a panel on the head that is also magnetic that comes off. So this is not a real antenna, it's a fake antenna. The other antennas are inside of her head, but you can do stuff like this one that I 3D printed, which this is a thermal camera. So she can see heat if you wanted to add that to her. And these wires can then plug into your Arduino backpack. So those are some of the main things. I think there is also another camera in the head that maybe I mentioned that for faces and object recognition and stuff like that. So those are the main pieces of Misty. And then there's lots of tools on your computer so that you can easily program skills for her. You can say when you say drive around, look for Ian. When you see Ian, play this message and then come back to me. So you can do stuff like that. So right now Misty works with JavaScript. Although you can also program her in Python, and some people are starting to port her languages to other languages as well. But those are the main ones. Yeah, definitely. I mean, JavaScript is relatively easy, and we're going to be putting out lots of example code on how to do different things. So a lot of it is just copying and pasting lines of code. And then once you sort of copy and paste some different things to get Misty to drive around and maybe recognize a face, then you can start to understand what those lines of code mean, and then you can start to get more advanced and more complicated things. We also have some tools that are just basically websites. So Misty basically has a little web server inside of her that you can go to and pull up different dashboards, like in your Firefox or Chrome or whatever your web browser is. And then you can command her from that as well. I would say in the next 5 to 10 years, we're definitely going to see a lot more robots around us, definitely a lot more robots in offices and homes. It's probably more on the, 15, 20 years before we start to see more of that. But it's definitely going in that direction.